Okay, good morning. Welcome, geometry friends. You have arrived. This is our last homework assignment, or at least our last lesson, new lesson. We do have a review left, but our last lesson, our last video for 2019-20, 11.5 angle relationships in circles. For those of you who completed the journey and you didn't give up, well done. Really appreciate your efforts and I'm proud of you. And let's go ahead and bring it home with 11.5 angle relationships in circles. Okay? Nice little reward here as we get to our definitions. There are none, not applicable. No new definitions. Just two new ideas about angle relationships within circles. Okay? And so the one question we need to answer here is what is the relationship with angle measurements depending on where the vertex is? That's the key. Depending on where the angle is crossing or originating from, either on the circle, inside the circle, or outside the circle, that's what makes the difference. So in the last chapter, we actually already did what happens when it's on the circle. And so on the circle means you've got your angle and you've got your vertex, and see it's right here on the circle. Okay? And so we learned that this angle here, we'll call it angle 1, okay, that angle 1 has a specific relationship to this arc. We'll call this arc AB. And we learned that this is always half of that. So that, in other words, arc AB, let's just say it this way. Angle 1 is equal to half arc AB. And so whatever this is in degrees, this is half of those degrees. So if this was 100 degrees, this would be 50 degrees. So the angle is half of the arc. Okay? And so these are going to be some variation of that same relationship, but always start with what the simplest one is if it's on the vertex. Okay? If it's inside the vertex, so now we get something like this. Okay? Where now we have a vertex inside the circle. Okay, and now we have angle 1 is right here. Quick thing to note, you have two angles. Just remember, these are vertical angles, and so these two angles are congruent. So once you know this angle, you already know this angle. And these are supplementary, so we'll come to that with some of the practice problems. But in this case, say we have arc AB. We're also going to have to take into account arc CD, because now here's the key. This angle creates two arcs, one there, usually one bigger than the other. But in this case, angle 1 is going to be equal to the sum of these two. So arc AB plus arc CD. Okay, so when it's inside, you actually add up the two created arcs. Oh, I'm sorry, and cut it in half. I knew that was too short. I'm just going to put it over 2. Okay, divided by 2. So this is going to be consistent throughout all three of these, half. So in this case, add up the two arcs, cut them in half, and then you have the angle formed inside. Okay, and that'd be the truth for this angle and these two over here. Okay, if I were to just write that the same way as I wrote the other one, angle 1 equals 1/2 AB plus CD. There we go. Okay. Then what happens if your vertex is outside the angle? So you have something like this. Okay. Where now my vertex is outside the angle. Okay. And we'll just call this angle 1. Doesn't fit inside. So that's angle 1. And I have now created, again, you'll always have created two new arcs, C and D. So this one here and this one here. So in this particular circumstance, it's actually just going to be the opposite of this. Is now actually AB minus CD cut in half is going to equal angle 1. So when the vertex is outside of the circle, angle 1 is going to be equal to 1/2. That's the same for all three of these. Times AB, arc AB minus arc CD. Now, in addition, it doesn't matter which one you put first. in subtraction, it does. And so the important thing to note here is this is the furthest away. It's also always going to be the largest, because when you're outside the circle, the bigger the angles, the bigger arc's going to be the one further away. So you could call this the furthest or the largest. And then this, the one you're subtracting from, is always going to be the closer. And when I say closer, closer to the vertex, the closest and the shortest. Largest, shortest, smallest. Whoops. Okay. So that order does matter. And that's just natural, because when you subtract, you usually want to take the bigger and subtract the smaller. So that should fall naturally, but just keep in mind, it's the bigger angle here minus the smaller angle here. Cut in half gives you this one here. Okay, so in general, not too difficult if you can remember just the different relationships. And we'll do now 3 practice problems as we walk our way through it. Okay, so question number 2. This is actually question 2. I got confused here. Question number 2 asks us to solve 3 problems from the book, starting with problem number 4. And so let's go ahead and make sure we solve for the right thing. Turn my page. Number 4 says solve for MNP. Okay, so that's it. One key thing here is make sure you clearly identify what you're trying to find. So we're trying to find angle NMP. Okay, so that's straight enough. It's a beginner one. I'm trying to find this angle. So we can go ahead and look at what situation are we? Where's the vertex? Is it on, inside, or outside? Well, this vertex is on. So this is very simple. This is actually just right from 11.4. This angle is half of this arc, because this is the intercepted arc that the angle intercepts, 238. So all I do is 238 divided by 2. Okay, 238 divided by 2, and that's going to give me 119 degrees. That's it. So fairly straightforward if it's on the circle itself. The angle is always half of the intercepted arc. Okay, let's go ahead and look at 2 more. One of each scenario, as you can see. Number 6, we need to find angle. Always check, are you finding an arc or an angle? We're finding, on number 6, it says find the angle HFG. So HFG. So we're finding this guy right here. Okay, now notice our vertex is inside the circle. So that means we're going to add. We're going to add these 2 because they give us nicely both intercepted arcs. So that we learn that this inside angle is the addition of the intercepted arcs cut in half. So this is simply 23 plus 59 cut in half. And that's going to give us our angle. Okay, so those add up to whatever that is, 70, 82. 82. 1/2 of 82 equals, oh, my pen's finally dying after all these wonderful videos. Let's go get my other one real quick. Thank you, Red Pen, for your faithful service. Ready for summertime. Okay, so 1/2 times 82 is just 41. So HFG is 41 degrees. Okay, quick thing to note, if they asked you for EFJ, if they asked you for this angle here, it would be the same because it's also 41. Also keep in mind that we could easily find HFE. We're going to see one on the classwork like this. These are always supplementary, so I could see that that's actually 180 minus 41, which is 139. So this is 139. So once you find one angle, you know all the others very quickly. But again, notice back to the basics. We added the 2 intercepted arcs and cut them in half because this had a vertex on the inside. Whereas here's our last one for the homework. Nice short homework today. We can see, look, our vertex is outside. Okay, and so we're going to have to use the different relationship. I think we're just finding, go to number 8. We're trying to find x. So we can see x intercepts a close arc here and a larger arc here. And because it's outside the vertex, we know that we're going to subtract. So it's 161 minus 67. And then that is cut in half. And that's going to equal my x. Okay, so 161 minus 67 is 94. 94 cut in half is going to be 47. 47 degrees. So there she is. So fairly straightforward. First three basic types of problems, one of each. You'll see the classwork video if you want more help. They'll get a little more complicated by throwing more confusing pictures. They'll just draw lots of extra lines, and you'll have to go through a few extra steps, but those are the basics. Vertex on the circle, where it's just half relationship. The arc the angle is half of the intercepted arc. If the vertex is on the inside, then you're going to add up the intercepted arcs and cut them in half. And if the vertex is on the outside, you need to subtract the two. Notice, just always subtract the smaller from the bigger, and then cut it in half, and then you'll have the external angle. Okay, well, that's it. That was our last homework of 2020. Glory to God, took us just over 11 minutes. And I'll see you for a couple classwork problems. We just have classwork, a little bit of review, and then our last celebration this week. And we're done. Here comes summer.